Hi, my name is Salil Nadkarni, and I'm going to be teaching proof by contradiction. Alright, so today we're going to try to prove that the difference between an irrational and rational number is irrational, right? And how we're going to approach this is using a proof by contradiction. So just a quick refresher onto what exactly a proof by contradiction is. What we're going to do is we can think about this in terms of natural deduction. We're going to start with not P, right? Where P is our premise, which is in this case the difference between an irrational and rational number is irrational. We're going to end up finding that this original premise is false using a contradiction, right? And we can think about this inside of an assumption box. And in natural deduction, what does this kind of look like? Does anyone have any ideas?
Not P.
Right, it'll be a not introduction, right? So we can think about this as not P, right? And this is logically equivalent to P, which gets us to our original premise, which is what we're trying to prove, right? Okay, so to do this proof by contradiction, I think the first most important thing that we're going to need to think about is what a rational number is. So does anyone have an idea of what a rational number is?
It's an integer divided by an integer.
That is kind of true, but you're missing something rather important. What has to be true about the integer being divided?
It can't be 0.
Exactly, right? Because an integer divided by 0 is not a rational number, right? So we're going to say that the difference between, we're going to write this out, right? So we're going to write our negated statement out. So we're going to say, hey, we have some rational number minus some irrational number x. So x is irrational, okay. And we're going to say that that is equal to an rational number, right? So c divided by d, where x is irrational, a, b, c, and d are elements of the integers, and b and d are not equal to 0, right? So what we can do from here is we can do a little bit of algebra. So we can add x to this side and subtract c over d to this side. So we end up with a divided by b minus c divided by d is equal to x. We can flip the sides and then bring this under a common denominator to get x is equal to ad minus bc over bd, right? So these are all integers, correct? So what can we say about these integers, given what we know about how integers subtract and multiply?
That they have to be integers.
As well, right? Because integers are closed under subtraction and multiplication. So we know that this numerator is going to be an integer, and we know that this denominator is also going to be an integer. And what can we also say about this denominator because of what we defined b and d as them not being equal to 0?
They're rational.
Not that they're rational, they're also going to be an integer because remember, integers are closed under integer multiplication, but we know that it's going to be a non-zero number. And since the top is an integer and the bottom is a non-zero integer, what can we say about x?
It's rational.
It's rational, exactly. And this is where we find our contradiction because we want to actually prove that this number, we want to prove that it is irrational. We said over here that x is going to be irrational, right? So this is our contradiction, right? Because this shows that x is rational, but we assumed x is irrational. Therefore, our premise is proven by contradiction, right? So are there any questions for the class in general?
Why are we using proof by contradiction?
Right. So when it comes to approaching a proof problem, there are a lot of ways we can do it. For this specific proof, the reason I chose proof by contradiction is because it's very hard to prove something is irrational, right? Whenever we try to prove something is irrational, what we're trying to prove is that it is not rational because we have a concrete definition for what a rational number is, right? It is that we have some integers a and b, where b is not equal to 0, like our rational numbers is going to be a divided by b, right? And we don't have that same intuitive definition for irrational numbers. So that's why we're going to use proof by contradiction, because we have that not baked in, right? Okay. Thank you so much for listening to me teach. I hope you guys enjoyed. Bye-bye.